Good day and welcome once again. In today's class, we want to prove that every convergent sequence is bounded. We can also be told that prove that a convergent sequence A sub n is bounded. It is still the same proof. Prove that a convergent sequence is bounded. We are still looking at the same thing. So where do we begin from? The first thing is to make an assumption. Since we want to show that the convergent sequence is bounded, let us assume that the sequence is convergent. Therefore, let A sub n be a convergent sequence. Let A sub n be a convergent sequence. That implies that A sub n converges to A contained in R. And by definition of convergent sequence, let's quickly recall the definition of convergent sequence. Recall the definition. What does it say? It says for any epsilon greater than 0, there exists k in n such that what? The absolute value of A sub n minus A is less than epsilon for all n greater than or equals to k. If that is true, we now want to show that our A sub n is bounded. We want to show that the sequence A sub n is bounded. Now let's also try to recall the definition of bounded sequence. It says what? A sub n is bounded if and only if there exists L in R and U in R such that what? L is less than or equal to A sub n less than or equal to U for all n contained in the set of natural numbers. If that is true, we'll now begin from here. That is the definition of our convergence. If that is true, A sub n minus A is less than epsilon. By equivalence, it means that minus epsilon is less than A sub n minus A, and that is less than epsilon. If we add A all through, we have minus epsilon plus A to be less than or equal to what? A sub n minus A plus A to be less than what? Epsilon plus A. That removes that. We have A minus epsilon to be less than or equal to A sub n less than or equal to A plus epsilon. And if our epsilon is 1, then A minus 1 will be less than or equal to A sub n less than or equal to A plus 1. Therefore, if we compare this with the definition of bounded sequence, compare this with the definition of bounded sequence, which we have here, L less than or equal to A sub n less than or equal to A plus 1, less than or equal to U rather. Therefore, we can define our lower bound now for our sequence A sub n to be the minimum of what? The minimum of all the terms in the sequence A1, A2, A3, down to AN, and down to what? A minus 1. And we can also define the upper bound to be the maximum of what? A1, A2, A3, down to AN, and down to A plus 1. Therefore, truly, our A minus 1 is less than or equal to AN, less than or equal to A plus 1, less than or equal to A plus 1. And that is our definition for bounded sequence. Therefore, the convergent sequence A sub n is bounded. So convergent sequence A sub n is bounded. Therefore, we can say that every convergent sequence is a bounded sequence. Every convergent sequence is a bounded sequence. However, the converse of this statement is not true. The converse of the statement is not true. And what is the converse? We'll just quickly bring that out. But this is the proof we want to show. But we just want to show that the converse is not true. The converse is not true. It means that what? This implies that what? Every bounded sequence need not be convergent. And we can show that in the example below. Consider the sequence below. Minus 1 raised power n as n moves from 1 to infinity. What are the terms of this sequence? We know that the terms of this sequence juggle between minus 1 and 1 to minus 1 to plus 1 again, and then to minus 1 to plus 1, and it continues like that. The lower bound is minus 1. The upper bound is plus 1. Therefore, it is bounded. However, this sequence is not convergent. However, it is not what? Convergent. Why? Because when n is odd, it converges to minus 1, converges to minus 1, and when n is even, it converges to plus 1, therefore oscillating between minus 1 and plus 1. As such, it is not convergent, but it is what? It is bounded. That's why we said that the converse of the statement, every convergent sequence is bounded, is not true. And that is what we have shown in the example below, that every bounded sequence need not be convergent. Thank you. God bless you. If you have gained anything from today's video, share it, like it, and give it a thumbs up. Thank you. God bless you. I see you in the next video.